Every act of measurement is an act of faith. We trust our rulers, scales, sensors, and instruments to reveal something real, something stable beneath the noise of the world. But between what is and what we record, there lies a gap, the error. Sometimes it is infinitesimal, sometimes decisive, yet it is always there, whispering that precision is not perfection. We build processes to shrink that whisper. We standardize procedures, publish protocols, document tolerances. Still, even the most careful measure is a translation from reality into representation, and every translation loses something on the way. The error of measurement is not just a technical nuisance, it is a philosophical mirror. It reminds us that every number hides uncertainty, every observation hides bias, and every data point is a translation of reality into human terms. To understand the reliability of data is to confront the limits of knowing, and, paradoxically, the very foundation of science itself. This is why honest reporting always includes context, the instrument, the environment, the method, the variance, the confidence interval, the caveats. Without them, precision is theater. With them, precision becomes a disciplined humility. The fragile architecture of precision. No measurement is ever exact. Instruments bend, sensors drift, hands tremble, temperatures fluctuate. What we call precision is often a negotiated illusion, an agreement to ignore errors below a certain threshold. Behind every crisp decimal place sits a chain of assumptions. Linearity across the instrument's range, stability over time, insensitivity to ambient conditions, and an operator who follows the same steps each time. Break the chain anywhere, and the decimals lie with confidence. In physics, the uncertainty principle is not merely a quantum curiosity. It is a truth about all observation. Every tool filters, rounds, or averages the world. Even a simple ruler introduces interpretation. Where does the edge of an object truly end? The mark you choose is already a model, a decision about boundaries, parallax, and human sight. Micrometers and interferometers only move the boundary. They do not erase it. Scientists classify these deviations into systematic and random errors. The first arises from consistent bias, a miscalibrated thermometer that always reads 1 degree too high, a scale that zeroes a gram too heavy, a timing circuit that starts just a fraction late. Systematic errors are seductive because they are invisible within a single run. They make results look precise and reproducible while steering them astray. Random error comes from the world's restless grain. Thermal fluctuations, electronic noise, stochastic processes in materials, human motor variation. Its traces are the scatter around a mean. We tame it with repetition and statistics. Both are woven into every experiment, and both shape the confidence we can have in any result. Calibration with trusted standards hunts the systematic. Replication, averaging, and variance estimation discipline the random. Error propagation tells us how small uncertainties in inputs swell or shrink through a model, reminding us that a fragile step can dominate the whole chain. Precision, then, is not the absence of error, but the mastery of its behavior, the willingness to measure the uncertainty as seriously as the quantity itself. The reliability of data and the trust we build upon it. Data is not truth. It is evidence, and like all evidence, it must be interpreted, cross-checked, and tested for reliability. A dataset is a story told in numbers. Good stories show their sources, their omissions, and their doubt. In science, this means replication, seeing if an experiment holds under different conditions, by different hands, with different instruments. Replication is not busy work. It is how we separate a robust phenomenon from a delicate artifact. When results cannot be replicated, the fault is not always deceit. It may simply be the quiet tyranny of measurement error at work. An unreported change in ambient humidity, a different brand of reagent, a firmware update that altered timing by microseconds. Statisticians call this the signal-to-noise ratio, the strength of what we can infer against the hum of uncertainty. Too much noise, and patterns dissolve into coincidence. Too little awareness of noise, and coincidence masquerades as discovery. We protect ourselves with pre-registration, power analysis, holdout sets, blind protocols, and out-of-sample tests. Each is a way of asking, is the pattern real, or did the process learn the quirks of the instrument rather than the contours of the world? This is why peer review, open data, and calibration standards matter. They are not bureaucratic rituals, but acts of collective humility, acknowledgments that even the best instruments can deceive, and that truth requires redundancy. Version datasets, detailed lab notebooks, and machine-readable metadata allow others to rerun the journey, not just admire the destination. Trust, in the end, is an infrastructure we build around data. Documented pipelines, transparent assumptions, and the courage to publish negative results when the signal fails to rise above the noise. The everyday tyranny of small errors. Measurement errors are not confined to laboratories. They shape our daily lives in quiet, invisible ways. A retail scale that rounds up by habit changes margins across thousands of transactions. A step counter with a lively accelerometer persuades us we walked farther than we did. A home energy monitor that samples too sparsely underestimates peaks and overestimates savings. Consider the speed camera calibrated to detect vehicles exceeding 30 miles per hour. A minor misalignment of 1/2 can turn an innocent driver into a lawbreaker, or let a speeding one slip away. We assume such devices are infallible, yet every radar gun, lens, and timing circuit operates within margins of error defined by manufacturers and regulators. Fairness here is partly a policy choice. Do we set thresholds with buffers to acknowledge uncertainty, or do we punish at the razor's edge and pretend the edge is real? Or think of medical scales and blood pressure monitors. A 2% deviation on a home scale may seem trivial, but over months it can alter diagnoses, prescriptions, and even how we perceive our own health. White coat hypertension is not just psychology. It is measurement design colliding with human physiology. The cuff size, arm position, rest period, and device algorithm all shift the reading. Two numbers, same person, different protocols, apparently different health. GPS errors can misplace you by several meters, harmless for navigation, disastrous for autonomous vehicles or precision agriculture. The world's logistics depend on clocks and coordinates that must be constantly corrected for drift, relativistic effects, and atmospheric noise. Even climate models must account for the cumulative propagation of measurement errors from millions of sensors, satellites, and proxies. A slight bias in a long historical series can tilt a trend. Careful homogenization and uncertainty bands restore balance. We live surrounded by approximations. The world functions not because our measurements are perfect, but because our systems tolerate imperfection gracefully. Good systems absorb noise with buffers and guardrails. Debounced buttons, hysteresis thresholds, median filters, sanity checks. Robust design assumes the thermometer lies a little, the human slips a little, the network jitters a little, and still the bridge stands. When error becomes meaning to measure is to simplify. It is to declare that what can be quantified is what matters. But this simplification has a cost. A KPI can sharpen attention and also narrow vision. Optimization can improve the metric and impoverish the reality it was meant to reflect. What we measure, we manage. What we cannot measure, we are tempted to ignore. Philosophers of science, from Feyerabend to Kuhn, have long warned that excessive faith in data can obscure the contexts that give it meaning. Paradigms decide which questions make sense, which methods count as valid, which anomalies are noise, and which are crises. When we treat numbers as absolute rather than interpretive, we mistake the map for the territory. Worse, we retrofit the territory to fit the map. An error in measurement is not merely a technical flaw. It is a reminder that the observer is part of the system observed. Our instruments, languages, and frameworks shape what we call data. Thus, measurement error is also epistemic error, the limits of human translation, the friction between reality and representation. A better sensor helps, but so does a wider lens, a willingness to combine quantitative with qualitative, model with narrative, dashboard with diary. Understanding this does not weaken science. It strengthens it by returning humility to precision and context to calculation. We can hold two truths at once, that careful measurement moves the world forward, and that every measurement is a situated act made by someone somewhere for a purpose. Meaning arrives when we keep both in view. The human margin, living within uncertainty. We crave certainty because it feels safe. Numbers promise control, prediction, mastery. But the margin of error teaches a subtler wisdom, that life, like science, thrives within boundaries of imperfection. Craft, judgment, and ethics live in the space that equations cannot close. A perfectly measured world would be a lifeless one, static, mechanical, unambiguous. The same tolerance that allows science to progress allows humanity to coexist with its own fallibility. We calibrate, correct, and iterate, not because we expect perfection, but because we accept its impossibility. We choose policies with buffers, design algorithms with guardrails, and lead teams with slack, not wasteful slack, human slack, the kind that keeps a system kind when the numbers are sharp. So the next time a speed camera flashes, a thermometer disagrees, or a headline proclaims a statistically significant finding, pause. Ask about the instrument. Ask about the protocol. Ask about the uncertainty. Behind the numbers lies a dance between reality and perception, a reminder that truth is not found in eliminating error, but in learning how to live with it. Mature systems and mature people carry their confidence and their doubt side by side, precise in method, generous in interpretation, honest about the margin that makes us human.